Good afternoon, boys and girls. I've received a lot of messages from you asking me to calculate the vertical exaggeration. So what I'm going to do, I'm going to use the Western Cape paper for 2025. The paper that was written by the Western Cape provincial paper. So this paper, it has got they were asked to do the cross section and also intervisibility. So what I'm going to do, I'm going to use this to calculate my vertical exaggeration, because I have got the information about the vertical scale, which is 1 centimeter equals 20 meters. That was used as the vertical scale. You can see here 60, 80, 100, 120 and 140, which means here you can see 1 centimeter is equivalent to the 20 meters according to this vertical scale. Then I'm also going to use the horizontal scale, as you can see, of the topographical map, which is 1:50,000. So this is the information that you need when you are calculating the vertical exaggeration. I'm going to use both those two scales, but I will be demonstrating it on a whiteboard. Okay, so the question there reads, calculate the vertical exaggeration. I'm reading this. Calculate the vertical exaggeration of the cross section. I've already shown you the cross section. Calculate the vertical exaggeration of the cross section. The formula for vertical exaggeration is your vertical scale over the horizontal scale. This is what I'm going to calculate. Unfortunately, I don't have the map, so I won't be able to answer some of the questions, because there will be a need for a map in order for me to give you the correct answers. But what I want to emphasize here is how you calculate your vertical exaggeration. So calculate the vertical exaggeration of the cross section, then vertical exaggeration, vertical scale over horizontal scale. I'm going to take you through the process of how you do it. So there is your cross section. It has got the vertical. You can see on this y-axis the vertical scale, which means from here 20, 60, 80, 100, 120, 140. So our 1 centimeter equals 20 meters has been used as our vertical scale, and this is our horizontal scale. So welcome, good afternoon. This is what we got from the paper. Unfortunately, I don't have a hard copy. I have a soft copy in my laptop. So here we are going to calculate what we call the vertical exaggeration. That's what we are going to calculate. This is the diagram of the cross section that we had from the question paper from Western Cape. And what we have from this cross section, we have got the vertical scale. You can see here 60, 80, 100, 120 and 140. I've shown you this cross section. Then here, these are the features that you find that are actually along the cross section. So here is our horizontal scale. So the first thing that you need to do when you're calculating your vertical exaggeration is you need to know or to understand what is the formula. What is the formula for calculating the vertical exaggeration? So vertical exaggeration is equal to your vertical scale over your horizontal scale. That is the formula for vertical exaggeration, your vertical scale over your horizontal scale. But one thing that you have to take note of is both your scales are supposed to have the same unit of measurement. So what I'm going to do, I'm going to make sure that my horizontal scale and my vertical scale, both of them are in centimeters. Remember, from our question paper, it was saying 1 centimeter to 20 meters. So in order for me to change this into centimeter, I have to multiply by what? My 20, I have to multiply my 20 meters. I have to multiply my 20 meters by 100. Why am I doing this? Because they are 100 centimeters in a meter. So I want to make sure that I have the same unit of measurement, because this is in centimeters. This has to be in centimeters as well. So I'm going to change my 20 meters into centimeters, which means I multiply by 100. That will give me 2,000 centimeters. So it means here, my vertical scale, I have converted it, I have changed it into centimeters, which means the most important thing is your vertical scale and your horizontal scale. Both of them are supposed to have the same unit of measurement. even if I was going to use the meters, which means this one was going to be 20 meters and this was going to be 500 meters. But let's use it the way that it is. So here you've got your 60, 80, 100, 120, 140, which means your 1 centimeter is equivalent to your 20 meters. That is the vertical scale. That is the vertical scale. So I've changed this vertical scale, which is 1 to 20 meters, to centimeters, because my horizontal scale, which is the scale of the topographical map, is already in centimeters, which is 50,000. So how am I going to calculate it? I'll say now, what is my vertical scale? 1 over 2,000, okay, divided by 1 over 50,000. Okay, right? I can put the unit of measurement, of course. It's very important because we are using the same unit of measurement. I'm using the centimeters. So I'm going to have 1 over 2,000 centimeters. I'll invert it. Then it will be 50,000 centimeters over 1. Okay, I'm not yet done. Then from there, 0, 0, 0, 0 here, 0 there, 0 there. Then 2 here, 1, 2 there is 25 times. So which means my answer there is 25 times, which means my vertical scale has been exaggerated 25 times. That's what it means. That's how you calculate your vertical exaggeration. So the most important thing is obviously it is intertwined with your cross section. That's why you see from the question paper that I showed you, they started off by asking question on the cross section. This is our cross section. Of course, it shows from G to F. These are features that you find along the cross section. Okay, then from there you were given your vertical scale. You can see on the y-axis 60, 80, 100, 120 and 140. Then here at the bottom you are just given the horizontal scale, of which the horizontal scale is the scale that you are going to use. So from there, what is the formula? Your vertical exaggeration is equal to your vertical scale over your horizontal scale. What is our vertical scale? We are given it as 1 centimeter to 20 meters, which means our scales, both of them are supposed to have the same unit of measurement. That's why I converted my 20 meters into centimeters, because the unit of measurement is supposed to be the same unit of measurement, same unit of measurement. That's why I have changed my 20 meters to 2,000 centimeters. I've also done the same here, is 50,000. So vertical scale over horizontal scale, which is 1 over 2,000 centimeters divided by 1 over 50,000 centimeters. Then from there you invert it, 1 over 2,000 multiplied by 50,000 over 1. You divide, obviously the unit of measurement divide each other, 0 here, there, 3 zeros, 2 into 50, that is 25 times. So this is how you calculate your vertical exaggeration. This is how you calculate your vertical exaggeration. I'm going to change also the unit of measurement to meters so that at least you understand exactly where I'm coming from. Okay, let me wrap off this and try to work out with the given scale. Okay, assuming that I've been given 20 meters, okay? I've been given 20 meters, 1 is to 20 meters. Then I want also my horizontal scale to be in meters, okay? What is it going to be here? It's going to be 500. Why? Where did I get the 500 from? Because they are how many centimeters in a meter? It's 100. So I just simply said 50,000, which is in centimeters, divided by 100. That's how I got this 50 meters. So I'm going to calculate now in meters. You'll see that we get the same answer. Okay, so I'll say now, what is my vertical scale? That will be 1 over 20 meters divided by 1 over 500 meters. Okay, what do I have? 1 over 20 meters multiplied by 500 meters over 1. As I inverted now. So 0 here, 0 there, of course cancel each other, 2 here, 2 here is 25, which means it's still the same. It has been exaggerated how many times? 25 times. I've used the different measures or unit of measurement, but it still gives me the same answer. So what is only needed is to make sure that when you are doing your calculation, both your vertical scale and your horizontal scale are supposed to have the same unit of measurement. Just to sum it up, cross section, you can see these are the features that you find within the cross section. Of course, this is your vertical scale, which has been given as 1 centimeter to 20 meters. This is your horizontal scale. Remember, this one is in centimeters. Here is 1 centimeter on the map. This is on the actual ground. This is in centimeters. So what I've done on the second example is I have changed my 50,000 centimeters into meters. That's why I got this 500 meters, because I divided my 50,000 divided by 100, because they are 100 centimeters in a meter. So from there I use my 1 over 20 meters, which is my vertical scale, divided by 1 over 500 meters, which is my horizontal scale. So 1 over 20 meters multiplied by 500 over 1, I've inverted now. Then I'll say, of course, unit of measurement cancel each other, 0, 0 there, 2 into 50, that's 25. So I still have the same answers, which means you have to make sure that whenever you're calculating your vertical exaggeration, your scales have got the same unit of measurement. You cannot say centimeters here, then the other one has got meters. Make sure that they've got the same unit of measurement. Then the other concept that is also intertwined with the vertical exaggeration, they can ask you if there is any intervisibility between F and G. Between F and G, you can see that your G is here. So it's not easy for you to see this G from Fy, because there are obstruction along the view from F to G, which means there is no intervisibility. You can't see G from F. Remember, your G is here. There's a depression here. That's where your G is. Here is where your F is. So if you are at point F, you cannot be able to see here because it's far below. It's far below. Okay, it's far below. You can see there is obstruction, which means there is no intervisibility. But if you are to ask if you can see Fx from F, it means you are able to see. You are able to see X from F, which means there is intervisibility. You can see. It's clearly visible. That's what it's all about. Which means here there is intervisibility. Intervisibility. Okay, here from there up to there is intervisibility. Then from there up to there is no intervisibility. Why? Because they are obstruction. Okay, they are obstructions. Okay, they are obstructions. What do I mean by that? Because this one you can see that it's in this depression, so you cannot clearly see from F. So they are obstruction. That's why you cannot see from that point. So that is your intervisibility and also how you calculate your vertical exaggeration. Thank you.